the first thing to try and understand about this problem is what exactly are they asking for? So we see it's in the first quadrant. We see that this line right here is the line y equals x squared, and this line right here is a line y equals 2x. So maybe we'll just write that on here. This is y equals 2x, and this is y equals x squared. And we know that we can see that by this, the shape of the lines. So that shouldn't be a difficult part of this problem. The slightly tricky part of this problem is to see what are they asking me for. So they're saying that this region R is the base of a solid. So this is the bottom part of a solid. And each cross section perpendicular to the y-axis is a square. So perpendicular to the y-axis would be like a line like this. Now that's supposed to be a horizontal line perpendicular to the y-axis. And I'm not much of an artist here, but I have to visualize a square coming up from that region, so it looks kind of like that. And so like if I had another square over here, it would be coming up and it would look like that. And if I had a square over here, it would be up, look like that. And you can see that these squares would be different sizes. And maybe you can kind of visualize if I put a whole bunch of those together, I would have like kind of a strange looking solid. You need to kind of understand that before you can kind of proceed with the problem. So in this case, I am not revolving these lines around anything. I am trying to find out, well, let me just see if I can pretend to draw here. It would be kind of like this kind of a weird looking solid. You can maybe get a sense of it the way I'm doing it here, and it would kind of then come down to there and come down to there. And again, not a pretty picture, but maybe enough to give you an idea of what this thing would look like. And so I have a bunch of these squares, and if I gave them each a tiny bit of depth, then I would have the volume of each square. So what I need to do is have a sum of the volume of all of these little squares. So the area of one of these squares is this distance right here between these two lines. And then we're going to just square that distance to get the area of each little square, and then we're going to do a sum to sum them all up and find the area of the solid, the sum being an integral. So you might look at this picture and say, well, y equals 2x is above y equals x squared, and that is true. But remember, we are looking at the cross-section perpendicular to the y-axis, not perpendicular to the x-axis. So we need to translate both of these equations here into x equals instead of y equals. So instead of y, you didn't hear me say damn it. Instead of y equals 2x, we have x is equal to 1/2 y. And instead of y equals x squared, we have x is equal to the square root of y. Looking at it that way, I can see that in relationship to the y-axis, this one is the one that is higher, and this is the one that is lower. So each one of these sides here, or this side here, is equal to the square root of y minus 1/2 of y. That's what each side is equal to. And so when I want to find the area of each of these squares, well, I'm just going to square a side. And so I have the area is equal to the square root of y minus 1/2 y squared. And I do not want to FOIL it out because, as you'll notice, this is a calculator problem, so I'm not going to need to do any kind of much arithmetic. Now, the next thing we're going to have to figure out, since we're going to be integrating with respect to y, but we need to know what this point is right here. What's this point going to be? I know that this point here is 0, 0, so I know that the lower boundary of integration is going to be 0, but what's this upper boundary? And it looks like it's 4, but we can just kind of check that out because I'm going to go, well, where does the square root of y equal 1/2 y? And so I square both sides and I get y is equal to 1/4 y squared, and I want to solve that, so I'm going to go 1/4 y squared minus y equals 0. I think to make my life a little bit easier, I'll multiply through by 4, so I get y squared minus 4y equals 0, and I'll factor out a y, and I get y minus 4 equals 0. So I know that this point right here is, in fact, the y value is 4. So what I'm going to end up doing here is now I'm going to integrate from 0 to 4 my area. So I'm going to integrate from 0 to 4 the square root of y minus 1/2 y squared dy. And so pulling that up on my calculator, I'm going to go alpha F2, integrate. I'm going to go from 0 to 4 of, I'll put in a parentheses. Well, it is a parentheses, but I'm going to square it, so I'm going to put in another parentheses. So it's going to be the square root of x minus 1/2 x dx. Oops, see, I forgot again. I needed to square this. 1/2 x. Let's see if I can fix this up here. Put a parentheses and 1/2 x squared. No, it doesn't do it. Okay, pause. I'll fix it. I'm gonna let you watch me fix it, or try to. So 0 to 4. I'm going to put another parentheses. Square root of x minus 1/2 x. And I'll put in my parentheses and I'll square it. There we go. Now I have dx. And if I hit enter, I get 0.533, and that is one of the 4 answers.